Good morning. I didn't realize the time. I'm 1 minute behind my usual starting time. How is everyone today? Oops, I have my slides at my halfway through point rather than at the beginning. How are we all? We are here in the final week of COMP1511. I am giving you a slightly different perspective on my room because of this. Hang on. I have just recently purchased a new shiny thing full of LEDs, and you can tell by the amount of LEDs in this thing that's how powerful it is as a computer. You can always measure the strength of a computer via the LEDs. Trent, it is a Ryzen, yes. So it is a brand spanking new computer because I am getting ready for the holidays. So I don't know if anyone else is also getting ready for the holidays. And so I've had to shift my setup around a little bit. Okay, so as I was saying last week, we have finished showing all of the content that we're going to show for COMP1511. And now we're going to today be doing a bit of a review of everything that we've done. So I said we're going to do a speed run of the entirety of the course. But on top of that, we're going to talk about the exam, because I know that a lot of people are going to want to know what's in the exam and how to approach it and stuff like that. So we're going to cover that a bit today. Let's launch into the lectures, because I've obviously got slides for all this stuff as well. So last week, what were we looking at? We had abstract data types. And we'd kind of seen a bit of abstract data types before, right? Because we did the multiple file projects. I think that was week 6 or week 7. I was trying to make sure that I had actually spoken to you a little bit about splitting code up into multiple files before we launched into the second assignment, so I wasn't just dropping a whole bunch of new content on you at the time. But when we looked at abstract data types, we built stacks, and stacks is super interesting because they happen to also be the way that functions work, and so we learnt a little bit about that. And we also learnt that when we're using an abstract data type, it's not super important how it's actually built underneath. The thing that's important is it follows the rules that are set in the H file, and so we can do some interesting things. And so I showed an implementation using linked lists, and that was one that we kind of developed during the lecture. But then we also talked about the ability to, if we wanted to, we could have built them with arrays, and functionally while you're using it, it's actually quite hard to tell the difference between whether someone has implemented as an array or as a linked list underlying the abstract data type. And that's actually one of the most powerful things about the abstract data types, is they remain abstract. Like, we don't have to think too much about how they're built. We just use them and assume they follow the rules that they're supposed to be following. We also looked at recursion, and recursion's great because recursion is great, and recursion is great because recursion is great, and then when recursion finishes, it stops. So I always love joking about recursion because it's like self-referential functions end up being quite interesting. Raymond asks an interesting question there: is recursion in the exam? And so one could say that recursion is in the exam if recursion is in the exam. And if you want to use recursion in the exam, you can use recursion instead of other possible techniques for iterating through data. Tom says, I've turned into yoga. So the trick with recursion is that there are times that you can use recursion or you can use procedural I guess recursion is part of procedural programming in a sense. But I'm sort of referring to them separately. So you can use the way that we've been teaching you to just simply loop through things, or you could recurse through things. You know how, like, one of my examples was add up all the values in a linked list. And I said, we can do this with a while loop, or we could do this with recursion. So it's actually your choice whether recursion is in the exam. If you don't use recursion in the exam, you'll still be able to complete everything in the exam. There isn't. I mean, I think that there might be, but most of the time there's no specific programming solution that requires recursion that can't be done with what would we call it, declarative programming that actually like does each statement one at a time and doesn't do that kind of inverted function call thing. Yeah, but if you want to, you can replace all your loops with recursion. You could get away. I think you could potentially get away with doing the entire exam without using the word while, and instead doing recursion for every single loop in the exam. And I think you'd still get there. I think if I mean, even I have to turn my head backwards to think about whether you could do that, because recursion does involve you kind of thinking backwards about things. Carvin, what weeks does assignment 2 cover in terms of content? And Tom's got it there, it's like 1 through to 8. Nothing in week 9 is involved in the assignment. You can use recursion in the assignment if you want to. Knowledge of stacks, and obviously the assignment's using abstract data types. But the way that we gave you the assignment with just this is a multi-file project, that's enough to know what you're doing with it. It's nice to know how the type def works and stuff in the assignment, but once you sort of get a handle on it, you can just continue. Sean asks, can you tell us right now if the last question is going to be decimal spiral? The last question in the exam is not decimal spiral. The last question in the exam is... I don't know, when I looked at the last question in the exam, I thought it was easier than decimal spiral, but I don't know if that's 100% the case. I would accept an argument either way. They're hard. But anyway, we're going to talk about the exam today. In fact, I should get into the slides, because like a lot of your questions here, hopefully I'm going to answer during this lecture. Bonus marks, as Tom said, marks with a C, so not real marks, for doing the entire exam without while loops, and it is potentially possible. Yeah, and Tom's here today to answer a lot of questions, because Tom's doing a lot of the back-end work for the exams. Like, he's just getting all this stuff organized together at the moment. So he's got his head in the game at the moment on the exam, where I'm still focusing on delivering the lecture material, so he's going to help out if there are any questions. Okay, so today we're going to start off covering the exam. So we're going to talk about the exam, the format of the exam, and I'm going to give you some tips on just general ideas I have on how you may want to prepare for the exam. And then we're going to start the recap of the course. Like, I can't speedrun the whole course in 1 hour. I'm going to set aside 3 hours to speedrun the course. Like 1 hour, second half of the lecture today, and then 2 hours on Friday. And then we'll cover the entire course. Hopefully that speedrun will show you a summary of every single topic. And so you know kind of where your starting point is for studying. Oh, Miguel's asking for a solution to decimal spiral. There is actually, right? I think if you go back and look at that lab, there will be some solution stuff. Okay, what's in the exam? All the things. Wait, it's this way. All the things. Okay, so exact details on what's in the exam. Let me just move my face out of the way. So he's like all of the details. So if we were going to use specific words to talk about the exam, it is a open book take-home exam, which means you're going to be completing the exam on your own computer at home. We are still not in a situation due to the global pandemic. We're not in a situation where we're allowed to have everyone together in rooms for several hours at a time doing something like an exam. So you can do it in the comfort of your own home. I mean, personally, I'm a bit here and there about that. Like, yes, I would say the comfort of my own home, but I would also say the distraction of my own home. So it's going to be on your own sort of self-discipline to focus for this. So you complete it on your own computer. We will provide files for you to work on. In a sense, you will have auto test capabilities, and submission in the same way that you've been doing using terminal commands. So this is the way that you've been doing stuff with labs and things like that. Like you've been doing with labs and assignments, you can submit multiple times. We're just going to mark your final submission, so we don't mind if you want to submit multiple times, just on the fear that your computer might crash partway through or something like that. You can do that, and then your submissions will be on our servers no matter what. The exam is, actually I should go back to the time and date. The exam is starting at midday at Australian Eastern Daylight Savings Time. I think that is AEST if you're looking for the code. It's either AEST or AEDT. I think it's AEDT. AEST is Australian Eastern Standard Time. AEDT is... Oh, it's AEDST? Right, okay. Great. Let's just add more letters to it. Tom's got a better way of looking at it as UTC plus 11. This goes for 6 hours. You're not expected to need to use all of the 6 hours. But we've done it that way because we looked at a lot of the different countries that people are in, and hopefully that gives everyone at least 3 hours outside of the hours of midnight to 8 a.m. I think that's how we calculated it. We had previously done this as a 24-hour exam, but we've been trying to compress the hours because it's pretty bad if you're doing an exam and you're emailing us for help in the exam and we're not even answering because we're asleep. So we want to do it at a time where we can actually supervise it properly, but at the same time it's still available for everyone's timing. If you have any issues with the timing, let us know, because we've gone on the major demographics of where we know people are. So some in the USA, some in the subcontinent, India, etc., and some in China, and so we're looking at those time zones and hoping that we can get to everyone. So if you have any issues with the timing, if it's like really inconvenient for you, get in contact with us because we have other options. Okay, this week's labs and this week's weekly test will show you some of the exam stuff. So there's some exam questions and things, but in particular the labs this week have a practice exam environment. So we actually have the exam paper. It just doesn't have the same questions, and it doesn't have all of them. So we're just giving you some example questions, not the whole package of questions. During the exam, there is one official way that we will communicate, and it's via your UNSW email address. So make sure that your UNSW email address is accessible, make sure that you can read stuff in it. One way to check now is all of the course notices that we've been sending out. So usually 2 a week. There's a midweek and an end of week notice. Or sorry, start of week notice and midweek notice. They've all been going to your official UNSW email address. So you probably want to check in that email inbox and make sure that all these 1511 notices have been appearing. If they have, then you're probably fine. We've got the right email address for you. You've got the right way to access it. You will be sent the exam via that email address. So, you've got 3 weeks, I think, from today, 2.5 weeks, I think, from today to make sure that email address is working. So you probably want to check on that. I think the forum, as people are asking, the forum will be restricted so that you can't post anything by accident to the forum. Girachan's like, any time zone works. Girachan, I think you're one of the students who I know is in the US, so hopefully that time works for you. Okay, so when we say open book, I'm saying that you can use any resources that we've given you from the class, you can use any resources that exist online, but this is still an exam. So, an exam is an individual assessment. So we're saying that there should be no communication between students. We're not going to police this overly much. Like, I'm not going to just suddenly appear in all the Facebook Messenger group chats and WeChats and WhatsApps and everything that you have that you're using to talk to your friends and stuff. I'm not going like miraculously appear there and tell you to stop talking about the exam. We are going to check all of your code afterwards, and if there is a significant similarity with other people, questions will arise. So it's similar to the kind of checking that we're doing on all the assignments. We have already found some people who have been either working together or working off the same source material for the first assignment. So, I guess just a warning. I don't know if you're here in the lecture or not, or you're going to watch this eventually. If you have done that in the assignments, I would suggest very, very strongly not to do that in the exam. The exam's worth a lot more marks, and if we see that you haven't necessarily been honest with the exam, we'll probably fail you for the entire course, because the exam has parts of it where if you don't pass, you don't pass the course at all. And so if we don't get an honest idea of what you've done in the course, then we can't give you a proper mark for the course. So just, I know it's tough. I know it's been a tough year, and I know that there's often a very strong temptation to get more help than you should be getting on things like assignments. Like, it's really, really easy to talk to your friends about it if you have friends in the course, when we're trying to get a really, really individual assessment of everyone with these things. So just be careful with it. Like even if you have done something like that in the assignments, please don't in the exam, because it's worth a lot more to you, and it's much easier for us to just pull that out and say, look, if we can't get a proper assessment for you in the exam because you cheated in the exam, then we're just going to make you do the whole course again. We're not going to go easy on that kind of thing and let you sit the supplementary exam or something like that, right? So what we're saying is any communication about the exam that is within 24 hours of the start of the exam will be considered plagiarism. This is so that we cover any kind of extensions we need to give people. Like, we've had people who's I had someone who's had a power failure during the exam, and so so we had to just give them an extra day, so they had to get their power fixed and they had to fix it up. So we don't want you to immediately hop on forums and Messenger and whatever straight after the exam and immediately start discussing questions, because you don't know how long the extensions are that other people have. Also, no external help. So you cannot ask questions, so you can't just go, I'm going to copy paste the exam onto Stack Overflow and see if I can get someone else to fix it for me. The people on Stack Overflow are going to notice when you do that, and they're going to say, this is obviously an exam, can you please not do this, right? Also, no sharing of code with anyone outside the course. Actually, anyone inside the course, any students inside the course either. But you can, if you want to talk about code with the 1511 subject staff, it is highly unlikely that you will get a kind of response that you've gotten previously on forums or emails or talking to your tutors, if you ask COMP1511 staff, because we all know that it's an exam and we're going to tell you exactly how much you can know about that, which is usually the only thing we'll be allowed to say to you usually is, I can't tell you anything about what is happening with your code. I can tell you to read the question clearly again and see what you can do. That's usually going to be the response that you're going to get. You're not going to get help session level support in an exam. The exam is you and the code alone. We have to assess your own capability of being able to think your way around programming and then execute your thinking in C without any help. Otherwise, we don't get a proper assessment of how well you've learned stuff in the course. Gearchan, you help us out on Stack Overflow. Not necessarily. Yeah, so the way that you can think about this is when you start the exam, whatever's on the internet at the start of the exam is fine. Anything that's added to the internet after the start of the exam is not part of what you can use. So we've had issues like this before, where someone has uploaded one of the questions for the exam to one of those study sites, and then someone has posted a solution to that question on that study site before the exam was finished. and then everyone who used that solution was then under investigation for plagiarism. So it's probably much better not to get involved with anywhere that it may be uploaded or anything like that. So we have a special email address, as you can see here. Oh, I'm about to cover it up with the bottom bar there. cs1511.exam@csc.unsw.edu.au. So that's going to give us there's a bunch of us that are going to be watching that, so all the exam supervisors are going to be watching that. So if there's anything going on in the exam that you need to tell us about, that's the email address you'll use during the exam. So technical details of how this stuff is going to work. As I said before, your UNSW email address is important. You will receive an email a few days before the exam, and that will be the tester email, and it'll be the one you want to look out for. If you get the tester email a few days before the exam, you'll know that your email address is working, and then you'll be able to receive stuff for the exam. You can also check beforehand. Check, as I said before, for all of our course notices. The link to the exam will be available, but it obviously won't be turned on until the actual exam starts. So at 12 p.m. the day of the exam, you will, I think, Tom, if I'm correct, you will receive another email at that point saying that the exam has started, and then the link will become available. And then you'll have 6 hours to work on that and submit it. The type of commands that you'll be using will be in the practice exam, which is happening in the labs. So, for example, you have like a command that will fetch the exam, which is called prac exam in week 10, and then in week 12, I think the exam's week 12. If we consider the study vacation, they call it StuVac, is week 11. The exam, I think, is Friday of week 12. So you will be using this other command, 1511 fetch exam then. But all of this stuff will be documented. All of it will be in your email when you get it. Okay, so the format of the exam looks like this. This isn't 100% set in stone, but it's like 99%. Like we're already writing the exam under this format. But not to say in 2 weeks, if we see something really glaring that we want to change about how we're doing things, we will, of course, change it. We're not just going to leave it in this format if there's an issue. But it's highly likely to be like this. So 20 short answer theory questions. Some of these will be multiple choice. Some of these will be just like a few words of text or something like that. These will be questions about testing your understanding of things, and then the 8 practical questions are like testing whether you can write code or not. So the short answer questions are things that we have not asked you before, because they're not the kinds of things that we necessarily do often, although some of the tutorial questions really kind of match up with those. And the practical questions are very, very much like the lab and weekly test questions. As you can see, 8 times 10, 20 plus 20 times 1, that adds up exactly to 100. I mean, like, the marks are not actually 100% of your marks for the course. I think if I recall correctly, it's worth 45% of the course. So it is nearly vital to get decent marks in the exam if you want to pass the course, unless you're so super confident that you've got pretty much 100% in everything else in the course, and you're happy with a pass and you want to throw the exam. You still can't entirely throw the exam. We've got some things in the exam you have to do to prove your competency, but we'll talk about that in a second. Mihir is asking, is the theory like definitions? No. I hate those questions. You know those exams, it's like, what does this acronym stand for? And it's just like, why are we bothering? Like, I could say, like, I will ask things in the theory section that are specific to your understanding of programming, but it's not going to be like, I don't know, what is it, like, define a while loop or something like that. It'll be more like, here is a loop running, can you tell me what goes on inside this loop? And I may ask it in such a way that it's hard to actually just type that code in and see what's happening in the loop. You actually have to think about it. So it'll be stuff like that. David's like, how does malloc work? It'll be more like, I have asked a question before, and there may be one similar to this. Here is something that's using malloc. Where is the memory leak? And then you'll have to say, it's on this line because this thing here wasn't freed later, or something like that. Yeah. So it's that kind of thing where it's like, you got to really know what's going on, not just like, this is a name for something that we have and know what this name means, or something like that. Yeah. I've got some more details about these kinds of things, actually. Let's keep going. Okay. So aside from the technicality of the exam, I have some tips for surviving exams. So these are tips in general for surviving exams, but they work just as well for take-home exams, because, I mean, it's not that much different. We give you more time in a take-home exam because we know that you're potentially going to get distracted and stuff like that. But at the same time, you're still going to be programming intensely for a few hours. So, drink water. That's one thing. So the simple physicality of some of these things. Water and food are things that you should probably pay attention to, because they affect the way that your brain works, and if you're going to be really, really taxing on your brain, you probably want to give it all the fuel it needs. So, blood sugar affects how well you think. Dehydration affects how you think. So before the exam starts, you probably want to have an early lunch where you have a decent meal, and drink plenty of water so that you're ready to go. Don't necessarily have a gigantic heavy meal just before the exam, because then you'll go into a food coma and then you'll be slower and things like that. But make sure you're reasonably well fed. Take breaks as well. This is something like you've noticed in the lectures, like we take a break in the middle of every lecture. We don't think that well for more than about an hour. Sean saying bento box during the exam. You could actually snack as you're going through the exam. I think some of the good snacks for these things are like fruit and nut mix, that kind of stuff. Like things that have just like low constant energy input. I mean, I say that now and then I can just see in the back of my head, I can just see a whole bunch of like people doing the exam with like a giant can of Monster Energy drink or something. I'm just like, no, don't do that. Stuff that spikes your energy and drops you back off is pretty bad for long-term focus. So just be careful with that. The other thing is the exam was designed for 3 hours. It's hard in 3 hours, but I mean, it's an exam. It's supposed to be hard, right? Like if it's not hard, we don't get a proper assessment of what everyone's capable of doing. So you don't have to work for all 6 hours. If you do work for all 6 hours, I pretty much guarantee every single person here, if you work solidly for 6 hours, you're all going to reach a point where adding more time will not get you more marks, right? So this is something to think about. Like most people are going to max out on the marks they can earn in about 3 hours. And after that, you're just scrabbling at things and you're just making yourself tired for no particular reason. So, I would say plan for, I mean, depending, you could plan for 3 to 5, 5 is a long time, 3 to 4 hours maybe of consistent work, and you spread that out over the 6 hours, knowing that you'll probably hit a point, I mean, like you will, like everyone's going to reach a point where it's just like, I have exhausted everything I know about this course, and I'm not going to magically suddenly know more about this course by hammering at this same problem for another few hours. So those are my kind of general tips for the exam. In terms of preparation, a nice thing to do for preparation is to go through the list of the topics and make sure before the exam that you've at least looked at each of the topics and you have maybe taken down some notes saying, when I see this kind of thing, that means this topic. And then you can say, okay, go back to my notes about this topic. One of the nice things about an open book exam is you can write notes in advance, and instead of them being study notes you can't bring into the exam, they're study notes that you will always have with you during the exam. So you can prepare responses to questions in advance, in a sense. The other thing I would say is always have spare paper and a pen, pencils. I like to use multiple colors of pens. I think a lot of people like to use pencils because it's easier to erase them and stuff, but like when I'm going fast, I don't erase things. I'll just grab another piece of paper. But I like to have that kind of thing so that I can draw my diagrams. So we've seen this, all right? We've totally seen this, that linked lists are really hard to think around if you don't draw them. But if you do draw them, they get significantly easier. So use the tools you have available, right? It's going to be easier to work on these things in the exam if you've drawn pictures of them. See if there's any questions there. People are asking about other questions and things. We are going to release a revision page on the website soon. It's not exactly exam questions, but it's subject format questions. So things categorized into subject format, and those questions in there will be really similar to exam questions. I should also say people are asking about past questions and things like that. I don't know if you can tell. Actually, you probably can't tell because you haven't done the exam yet. But a significant number of your lab questions are past exam questions. A significant number of the lab and weekly test questions are actually either past exam questions or modified current exam questions. So what we're examining you on is no different from what we've been teaching you. And that is like part of the philosophy of the course in a sense. There's no reason to assess you differently from the way that we've been teaching you. So a lot of what we're doing with the format of things just follows on from the way we've been teaching. So the exam is not a big jump to a different way of doing things. It's actually just more of the same. Girishan's asking if we write tests in the exam, not in the same way as you're doing in assignment 2. So with the testing that you write in assignment 2, we have particular ways of checking whether that's working or not. We do need to do more hand marking for that. So it's not the kind of thing that we're doing for the exam. Whether you need to write tests every time you create a piece of software, I would say, yes, you do have to write tests, right? So, and also, the same way as you've seen both in labs and in assignments, the harder the code gets, the less auto tests we give you. So if you want to push into the levels where you're aiming for like 90 or 100 in the course, you know, like, so you're pushing into levels where you really don't need to. Like, I don't think there's any particular reason anyone needs to get 100 in a course. Like, anywhere between 85 and 100, you'll be acknowledged as having pretty much a full knowledge of the course. But if you're really, really pushing for that final bit, you're going to have to be able to do some of your own testing. There's going to be less auto tests. I always like to say, chill out. This isn't a big deal. This is just something that you have to work on. This is just a minor hurdle in a minor subject in a university degree that will eventually see you understanding programming in a significant way. But I know that not everyone's going to believe me if I say chill out, relax, and everything will be fine. So I'll try to say it anyway, and we'll see how we go with that. People asking about testing and stuff like that. Anu's asking about past exam papers. We don't release past exam papers, so the exam paper is in a sense considered to be considered to be property of the course, not to be shared around afterwards. You can always just, like, if you want to afterwards, you can talk about the questions, but we definitely don't want to see the exam turning up elsewhere online, having been uploaded somewhere or something like that. We're going to be using some of those questions in a modified format in the future, and it's unfair if people have seen it before. So we don't necessarily have past papers out there. Having said that, we've got like the practice exam and stuff like that. We do have information on the format and stuff that we're definitely going to tell you. So let's go into some of the details. So the quick questions, the short answer questions are things like, how well do you understand this? So there are warm-up questions here. So some of the warm-up questions are basically, what does this code do? And we'll give you the entire piece of code. And so you can look at that and you go, wait, if I copy paste this into gedit, save it, compile it, and run it. That's my answer. So some of the questions are going to be that easy, because when you consider like a couple of percent of the course, like 2-3% of the course, I'm happy to give out 2 or 3% of the course's marks just for you to be able to compile and run code and read what the output is, right? Because if you consider that is something that I taught at the very beginning, so it is worth assessing. You're not going to pass the course if that's the only thing that you can do, but you do deserve some marks if you can do that. So there will be some questions that are just like, what does this code do? If you're really quick and you're good at analyzing code, you won't have to type it in and compile it and run it. But otherwise, like, the fact that you can compile and run code and read the output is a skill. And so there'll be some of that. But the short answer questions will then ramp up into more difficulty. So as I said before, I might show you a piece of code and I could say something like, I say I, but it's not just me, there's other people writing bits of the exam as well. But we, I should say, could say to you in the exam, here is a piece of code, there is a problem in this piece of code. Here's multiple choice of the possible problems that are in this piece of code. Pick one of them, you know. Raman saying it doesn't matter, even if it said 1 + 1, I'm still going to get the computer to check. Yeah, I understand that that sentiment, because you don't know if there's a trick question or not. So sometimes the question is like, there's something wrong with this code somewhere, tell me what's wrong with this code, and one of the options might be there's nothing wrong with this code, and at that point you're like, oh, I don't know, right? So there will be issues like that. And so what we'll be testing is like your overall understanding of the concepts. So a lot of it is like, here's some code, what does it do? Some of it is, here's some code, where are the issues in this code? Or maybe track this variable in the code, and what is the value of this variable when we reach this line of execution, you know, things like that. The Week 10 lab has some examples of this. Is he saying there might be, will there be trick questions? It's hard to say what a question is, whether a question is a trick question or not. So I have written questions in the past that you would consider to be quite devious, but they're devious in a way that they stop you from being able to pretend that you know something that you don't know. So I can ask a question which is about looping, and then when you're thinking about looping, you just go, why don't I just take the code from the question and run it and see what it does? But the way that I will phrase the question will be like, running it's not going to give you the answer. You need to know better about what's going on than running it. So that's the kind of answer to whether there's trick questions or not. I have crafted questions, specifically for this year, crafted questions that work in an online open book exam environment. So these are questions you can't just, like, if you type in significant amount of text of the question to Google, you don't get an answer. Like, it's not a concept that is simple to answer like that. It's not a definition of something. It's like, prove that you know this by using it, and then show me the result of the fact that you were able to use it. They'll be a bit like that. Raymond asks a very good question. How do we answer these questions? Because there's not like code that you submit. So, I love it when the question leads directly into the next slide. So, how are we going to answer these questions? You will be given a text file. So this is like a text file. We've got an example name for it. This is what we named it last time we did this. It was exam_MC, so for multiple choice. It's not actually just named after me. It's multiple choice. And what you do is, in that, there will be text that we've already put there with instructions on how to do everything. You will see one of these in the Week 10 lab. So the Week 10 lab actually has this file in it, the practice exam version of this file in it, and we'll use the same format in the main exam. So each of the questions will have some information in it, and then we'll have these big triple curly bracket sections that say everything between the triple curly brackets will be submitted. And the rest of it is stuff just for you to read, but everything in that will be submitted. So you will put your answers in the triple curly bracket bits, and those are the bits that we will read. We've been particularly nice and actually are auto-testing even your multiple choice questions. We're not going to tell you whether your answer's right or not, but we'll catch issues if you have answered something incorrectly. Not incorrectly, but in incorrect syntax or format. So if we said to you, please type in the two numbers that these variables have as values at certain point in a program or something like that, and you type in one number but not two, our test will actually tell you, are you sure that that's the answer you want to submit, because there's no way that that can be correct. So we're helping you out a little bit with your multiple choice there. David, what if multiple choice was named after Mark? Yeah. Also, as Tom says, in terms of like trick questions, we're not going to try to trick you. We're going to try to assess your knowledge sufficiently. So that's going to be more about whether you having to ask things in a particular way so that you can prove you understand something, not prove that you can just Google it. So we want to know that you've got a solid learning on this stuff. And if anything is just straight out Googleable, then it's not really worth me putting in the exam, because I'm assuming that in the future, when you have to do programming, that Google's always available, but your own knowledge you must be capable of using the stuff that's on Google, which is what we're actually testing. Okay, so you'll get a chance to practice on this in the Week 10 lab, so you can see what it's like to edit the file and submit it and things like that, and auto-test it. So my tips for this, I'm moving my face back down, but I'm going to have to move it out of the way of text anyway. It's a real text-heavy lecture. This is like a really long lecture, actually. Like, I think there's more slides in this lecture than I ever usually have. So these questions are the warm-up. My tips for these, as with anything in an exam, very different from what you'd do in a lab or a tute, I would say read all the questions before you start. So skim them, and what I often do is I have a piece of paper next to me and I skim the questions, and then I'll write down the numbers of the questions. So what I will do is I usually write down, I say what I will do, I haven't done an exam in many, many years, but still these techniques hopefully will help. I write down numbers for the ones I think I can answer really easily, and I'll say, okay, these ones I do first. This is my warm-up, because these ones I already know well. And then I can write down another column, the ones that I think are going to take a little bit more thinking, and then another column for I don't know what's going on. And so then what I'll do is I'll do the first column, then the second column, then the third column. So we're talking strategy in an exam here. All of these questions are worth the same amount of marks, which means you should be aiming for the easy ones to get more marks with less effort. And that is a strategy that you can use in the exam. I don't mind if people get a little tactical with what they're doing. So go for the easy marks, then spend more time on the harder marks only if you think you have more time. If you need to think about things more, if you're sure you don't know something, then you should potentially, so long as you've prepared a little bit in advance, you should know what topic each of the questions is about, and then you can go back and look at notes that you've made previously, or if things get really desperate, you can hit up the lecture videos and stuff. But we're not testing you as if you haven't watched the lectures. If we were testing you as if we hadn't watched the lectures, we'd have to give you a few weeks to do the exam. It takes longer than that to watch all of them. We're assuming that people have at least seen the course content enough to be able to go back through and go, okay, I'm going to skim this a little bit here. Izzy's asking you about whether you should skim the entire exam or just the short answer questions. This is up to you. I personally would knock over the short answer questions as my warm-up and then hit the practical questions afterwards. So I wouldn't read the practical questions until after I'd done my first or second pass through the short answer questions. It's not bad though to read the whole thing and get an idea about what's going on. Because you can also look at the long questions, and there's like 8 of them, and you can be like, I actually only need to answer sort of 5 or 6 of these, especially because 7 and 8, some people are going to look at 7 and 8 and just go, what? and that's fine, because there's a separation of marks in the course, and when you consider questions 7 and 8, are the differences between already getting an HD and getting 100%. It's a little bit full on. Yeah. MX is asking, what is the practice exam? The practice exam is lab 10. The majority of your 10th lab is this practice exam where you'll actually get a chance to try this thing out. Okay, so the practical questions, there's less of them, but they're worth more marks each. They're worth actually significantly more marks each, so that's why I talk about theory questions as a warm-up. When you think about the amount of time you're going to spend on the exam, if the theory questions are worth 20 marks in total, then you would probably only spend, in a 3-hour set of work, I would only spend maybe half an hour on those. So I'd look at them pretty quickly, fire off a little bit of work for a couple of minutes, and then if I can't answer them, I'd be like, no, I'm just going to go on to the practical questions, and I'll come back later. So the practical questions are like the weekly labs and tests. A lot of people are asking about like the difficulty of them. I wouldn't necessarily compare. Anson's asking about the difficulty compared to assignments. It's hard to compare to assignments. Assignments are designed for much longer work, not like, so I would say that the assignments are more of a grind, that you spend time on them, you learn a lot more, and you deliver a lot more content in a sense. The assignment is a short, sharp spike. The exam is a short, sharp spike where you have less time, but you have to be, you have to solve a problem of the same level of difficulty, but it will be a shorter problem that is maybe harder in a sense. So it's also harder because of the time pressure. Like, at no point would I consider that someone has to finish imagine having to finish the second assignment in 6 hours. That's a tall order. Whereas the exam is like, yeah, you do have to finish it in that time. So everything requires less code, less big setup, less like overarching theme and understanding and stuff like that. It's really just get it done fast. Yeah. Tom's like, what Mark said. Okay. So the practical questions are like weekly lab test questions. The same kind of setup. It's like, okay, here's a premise. Here's the thing you have to do. Here are some examples of input and output. Here are your auto tests. Now go and make this thing happen. Some of them will have code, so some of them will have, okay, here is a main file, a main function as well. The includes are all in here. You just have to edit this one particular function and make it work. So we're going to have that kind of thing sometimes. Sometimes we want to make sure that you know how to set things up. So sometimes we'll be like, no file, or if we provide a file, it is intentionally empty. Now you have to do all of your setup. So we want to see you know how to include the libraries and set up your main function, things like that. So it is going to swing both ways. It's not always going to be the same format. You're going to get auto tests. I will reiterate what I've been saying the whole way through the course. Auto tests are just examples. They are not the answer. Just straight out, do not count your auto tests and expect that to be the marks that you're going to get, unless it's 100%. So anything less than 100% could get any range of marks. You're unlikely to get 0 if you've passed some auto tests, but you definitely can. So if we ask you a question that says, go through this linked list, and I'll say, like, just an example question, this is definitely not in the exam, but if I said, go through this linked list and tell us if there are any odd numbers in the list. And so you could just answer yes or no. So you could very, very much easily for that answer yes 100% of the time and pass 50% of the auto tests and think you're going to be okay. You are not. Right? So that's what I'm saying. Don't count the auto tests. Use the auto tests as reminders for you to know whether your program is meeting the specification in every kind of area that it works in. But it's working to the specification that's important. We're not marking you for style in the exam, so you don't need to explain everything. I would still put comments in. As you've seen the way I code, I like to put comments in before I do things. It helps your problem solving. You will get more marks if you're organizing yourself properly to code. But we're not marking you on comments, so you don't have to write this code as if someone else is going to have to reuse it later, which is the way I want you to write code in general. But you can leave comments. There's nothing wrong with that. If that's your instinct to explain your stuff as you're doing it, then go for it, right? Eric's asking, earlier questions, if we pass all the auto tests, should we generally be okay? Generally, yes. Unless your program is, if test input is X, test output is Y. If test input is this, output is this. You know, like the dumb solution to auto testing obviously won't work. But if you're genuinely working on it and you're getting good responses about the auto test, I'd say yes, generally you'll be okay. It just depends how deep you go in. We will mark the questions later on where the auto tests start to drop off. The auto tests are never going to test every single possible outcome either, so you just got to be careful about that kind of thing. There are hurdles in this course as well. So there's two things that we require you to understand for us to say you have the basic competency for being able to do what we asked you to do in COMP1511. These are strongly linked to the content, I guess, in the two assignments. So if you've done the assignments, you don't have to have done well in the assignments. This is like stage 1 of both assignments level thinking. So there's an array hurdle and a linked list hurdle. You have to pass both hurdles to pass the course. So you have to get more than 50% of the marks. So you don't have to get perfect marks in one array question, and you have to get more than 50% of the marks in one linked list question. So the array and linked list questions in the set of 8 questions, these are the practical questions, alternate. So question 1's arrays, question 2 linked list, question 3 arrays, question 4 linked list. So we're going to alternate back and forth there. And so you can pass the hurdle with either question 1 or 3 or questions 2 or 4. 1 and 2 are easier. I'm just going to say that straight out. So it's easier to pass the hurdles with questions 1 and 2. We do expect the majority of the course, everyone who, like, if you've been watching all the lectures, going to the Tutor lab each week, and have even a vague, reasonable understanding of what's going on, these hurdles are not that big a deal. Sean says, I'll just get all 4. A lot of people are going to be hoping to pass all 4 of these questions. Because if you think about it, that's 50% of the practical questions. I think most people are going to be wanting to pass 50% of the practical questions. But this hurdle is here for if you want to know whether you should continue and take the subjects that follow on from this. If you can't pass the hurdles, the subjects that follow on from this are incredibly difficult. So, if you didn't pass both hurdles, if you didn't pass both hurdles, we're going to ask you to take 1511 again if you want to pass it. Because it's really kind of dangerous for us to put a stamp on saying, yes, this person knows what they're doing, they can continue. Because what we would be doing then is setting you up for dismal failure in the future if we just sent you off and said, this person doesn't know how to use an array, but now they can go on to more advanced computing, right? So you can see how that would cause a problem for you in the future. Okay, so my tips for the practical questions. I'm going to give you the same tip all the time. Read all the questions before starting. That way, what you do is you look at the scope of the problems you have in front of you and you decide how you're going to go. Again, pick the easy ones as you read them. The second part of the exam, which is the final 8 questions, are set up in a difficulty curve. So it's actually more like a step, where 1 and 2 are roughly the same difficulty, but they are one's on arrays and one on linked lists. 3 and 4 are roughly the same difficulty, again on arrays and linked lists. 5 and 6 are the same difficulty, but getting even more full on, both also separated into arrays and linked lists, although the area starts to gray a little bit there. 7 and 8 are very, very open, and they're just hard. So don't jump straight into code unless you're really, really sure of it. And you may be really, really sure with the earlier questions, but in general, don't jump straight into code. A minute or two or a couple of minutes drawing a diagram clarifying exactly what the problem is asking you, or writing down a plan of the steps that you're going to take, or separating the problem into parts and saying solve this, then solve this, and thinking to yourself, oh, I can write a function to do this, combine them together, and it'll be easier. So that kind of thinking, very, very good. Hopefully I've taught you how to do that by now. We've taught you a lot about preparing yourself to solve problems rather than launching yourself in and then finding yourself in the deep end. So take that learning and put it into effect. Everything that you've been doing in your labs and your tests, write code, test it, see if it works, go back to the specs, see if it works, auto test it, see if the auto tests are exposing any issues in your code and stuff. Do that kind of thing, try it again, that kind of cycle of stuff. Hopefully when you sit down and do the exam and do these questions, it should feel just like the labs. The feeling of building the code, rebuilding it, testing it, that kind of thing is the same kind of thing we should be doing. Again, and I said this before, do not count the number of auto tests. Marks are never based on the number of auto tests. We do the marks based on your capability to solve the problem. The number of auto tests are there to show you all the different possible ways that your code might not be working. So it's very, very different, the number of auto tests compared to the way we're going to mark it. So you could actually potentially not pass a significant portion of the auto tests just because your output was incorrect, but we may still give you a lot of the marks because we see that your algorithm underneath was correct. The only mistake you made was like the formatting of output or something like that. So you can get into a situation where maybe you'll get more marks than you thought from the auto tests, but maybe you'll get less marks. You don't know. And so that's the kind of thing where you will have to use the auto tests to tell you whether or not things are doing what they need to do, but not counting the number of them, right? So that's important. Yeah. So looking at some of these questions, the first hurdles, questions 1 and 2. Ooh. I thought I turned off my Slack. No one messaged me on Slack, tutors. I'm getting notifications. I'll turn them off in the break. So, question 1 and 2 is basic programming questions. So, we're thinking not necessarily early parts of the course, but the simpler parts of the of each of the concepts of arrays and linked lists. So we might use stuff like scanf and printf. We'll use variables like ints and doubles. We're actually unlikely to use characters and strings in the early questions. If statements and loops will definitely be in it. Question 1 will have arrays, and question 2 will have linked lists. But when we're using the linked list, we won't necessarily be doing insertion or removal in the early questions. We might just be looping through instead. So you think about it, you don't have to do as much pointer manipulation if you only have to loop through. You don't have to do any memory allocation or freeing if you're only looping through a linked list. Rosie's asking, how do you recommend we study for the final exam? I've actually got some notes about that later, but I reckon what you want to do is look at all of the pieces of content for the course and get a vague covering, at least of all of them, or if you're quite confident, get a comprehensive covering of all of those things. So review the entire course and go through and redo or do new versions of lab and weekly test questions for each of those topics, so that you think that you've got a good covering of lots of topics. Raymond's asking, if you're passing all the auto tests for questions 1 and 2, is that the right direction? I would say yes. If you're passing all of the auto tests without cheesing it, so you're not just passing only the auto tests, but you've built the program to the specification and it happens to also pass the auto tests, you'll be in a very good place there. Yeah. As Tom's saying the same thing as me. Yeah. So we've got an example here of a question 1. So I might give you, for example, question 1, a main function and an empty function called even lines. So there's this empty function called even lines that has an integer for the side length and an integer, a 2D integer array of a particular size. We're assuming, because it's in all caps here, that it's a hash define, and we've said edit this function even line so it loops through all the elements of an array, print out every line that has exactly one even number. So I can already think about, okay, how will I solve this problem? It's pretty easy. I'm going to loop through the 2D array. And when I loop through the 2D array, I am going to identify which of these lines in the 2D array. So we would have some other code that will build the 2D array for you out of this input. And so I'd have to look at this line here, and I'd say 13, 14, 15. I will check each of these numbers, so I'll do like a mod 2, right? So that's to check if it's even, and I'll see how many mod 2s come up here, and one of them comes up with a 0, so I'm just like, there is one even number, so I'll print out that line. This line here, I will say 16, 17, 18, I'll see 2 things that match a mod 2, so I'll say that is not the right number, so I won't print out that line. And I'll look at this one here, and I'll say 21, 23, 25, I did not match any even numbers here, so I won't print out that line. So as you can see, I'm checking whether you can loop through an array and pull out a certain kind of information, and then I'm asking you to just print out one line of the array. If you've worked on assignment 1, this is reasonably trivial, right? You already know how to work through arrays, and this is quite easy because it's just like, just loop all the way across a row. You don't have to pick particular starting and end points or anything. You just go all the way across the row and check for a condition. And if it's true, then you can go back to the start of the row, loop across it again, and print stuff out, right? So nothing overly difficult, but there will be some thinking, right? I'm not just going to trivialize this thing and say you can copy paste from lecture slides, because we've not done anything exactly like this in lecture slides, although we have similarly, you know, but this isn't a copy paste question. It's still going to be like, okay, think about how you're going to process this problem and then execute your solution to it. Example question 2 with linked lists. So perform some kind of computation on a linked list, not necessarily modifying the list itself. It's highly unlikely we'll ask you to do any modification in question 2. So given a linked list, print out the difference between the largest and smallest values in this linked list. So what I will need to do is I will need to loop through this linked list and keep track of the largest and smallest values as I'm looping through the linked list. So we've done something like this previously, where we looped through a linked list, and actually I can't remember whether we did it in lectures or not, but we've definitely done it in labs. We've looped through a linked list and we maintain one variable as we're going through. So this example is saying maintain 2 variables. Test each variable as we're going through for whether it's bigger than the biggest or smaller than the smallest, track both of those, and at the end -1 from the other. So we may have assumptions in here as well, like this linked list will never include negative numbers or something like that. But even if it did, that wouldn't be that big a deal. You know, I'm sure you'd still be able to work on this. So you can quite easily do this with a single loop through the linked list. You just go through and you go, all right, in one loop I'll find out the biggest and smallest, and I'll print it out. So this is the level of difficulty we're looking at for question 2. Jack was saying, do I discourage combining the detecting code and the printing code into the same line? I think you're talking about this particular one here. The way I would do this is I would do the detecting code and printing code separately. I would potentially have a separate function entirely that does the printing, because all I need to do is give it one of these lines. So I just give it one of these arrays. If we consider this to be an array of arrays rather than an array of rows, in a sense, I could say I could give it row 0 to print, and would print out row 0, and that way I can have a simple loop in that function and a separate one for the detection. So I think that's the way I would try to answer this question. Okay, questions 3 and 4 are harder hurdles. They're still hurdles. If you can pass questions 3 and 4, you probably already have passed questions 1 and 2. But we're throwing these in the hurdles just in case someone makes a disastrous mistake in question 1 and 2, and it's a simple mistake, but they're actually quite capable and they can pass in 3 and 4. It's definitely happened, before where someone has just read the question wrong in questions 1 and 2 and not tested it that thoroughly, so they don't get full marks, or they don't even get the 50% marks. But they're actually quite a capable student and they've just made a mistake and they still get the marks in question 3 and 4. Like, I don't want there to be a sort of single point of failure where you could fail the entire course just from making a simple mistake. It's very hard to do, and it's hard to make a simple mistake in a computing exam, because, like, I can understand you making that mistake in an exam where you just write the answers down, but in a computing exam, you don't write the answers down. You code the answers, you test the answers, you auto-test the answers, you submit the answers, which then does a compilation and auto-test pass on. All this kind of stuff. There's so many checks and balances that we don't really expect a silly mistake to cost that much in terms of marks, because even if you have a mistake like that, we're still going to hand mark all of the questions. So there's going to be a chance that we're going to catch if that's happened. Anyway, question 3 and 4, a little bit harder. So the previous ones effectively had a single loop through. I mean, the array one had a second loop through, but it was a very trivial second loop through. The harder hurdles will have multiple loops through the same content. So it'll be like, if I have to check every element in the list against every other element of the list. So I think we've done stuff like this in labs where it's just like, remove all the duplicate elements in a linked list. That means you have to loop through the linked list looking at each element. And then for each element in the linked list, you have to loop through again, looking for other elements that are same as that one, right? So that kind of double looping thing is the kind of question that we will potentially have in questions 3 and 4. So with linked lists, we're going to have insertion and removal. With arrays, I mean, we're using two-dimensional arrays already in question 1, so expect question 3 to probably still be using two-dimensional arrays, but asking you to do more difficult stuff in them. So you'll see where you go with those. When I sort of calibrate these, questions 3 and 4 are kind of like the weekly test question 2s, or hard ones. It's hard to say, right? Because if I say it's the same difficulty as question 2 in the weekly tests, you could look at question 2 in the week 3 weekly test, and you can say, how come the exam questions are so much harder than the week 3 weekly test? And that's because the week 3 weekly test was only on week 1 content. So all you had was if statements, right? So they're not as hard, but roughly week 2 weekly test questions. Tom's saying 3 and 4 could have scanf. Yeah, I actually had printf and scanf in questions 1 and 2. Because, like, there's always going to be printf, because if you don't have any output, then we can't test whether your programs are working or not. So yeah, 3 and 4 could have printf and scanf. 5 and 6 are getting to weekly test question 3, or even some of the easier challenges are going to be in questions 5 and 6. We're still separating those on arrays and linked lists, so 5 is arrays and 6 is linked lists. So question 5 is very likely to include strings, because this is the point at which we think that you have to use complicated arrays like that. We start to get into more complicated stuff, so we might ask you stuff like command line arguments and stuff like that there. If we're going to get you to work with linked lists, so this will be likely question 6, you're going to have to do adding and removing, so the harder stuff of working with linked lists. We're going to potentially, depending on the question, so unlikely for the array question, but reasonably likely for the linked list question, we're going to be checking your code for memory leaks and things like that. We might give you an abstract data type, so the same way as assignment 2. We're not necessarily going to ask you to build one from scratch. So we think that generally, like, to build up the multi-file project and stuff like that takes too long for the exam, but we might see if you can use one correctly by giving you one, but we won't necessarily ask you to, say, implement a stack from scratch without giving you the header file or something like that to begin with. Yes, and Tom's reminding me here, 5 and 6 is where the auto tests are going to tail off. they're going to start leaving a few little things out here and there. So we will have markers in the questions to let you know this, and you will have to, so this is, we're testing you not just on your ability to program to an auto test. What we really want to test you on is your ability to program based on the question and the problem provided. The auto test is just a support structure. It's like a crutch, and when we take the crutches away, you should be able to walk by then. But we're not going to ask you to do that until we've pushed you into the harder level of doing things. So you will be able to identify this. You'll be able to look at the question, and you'll run the auto tests, and you'll say, that's weird. The auto tests are never testing for these particular cases. Maybe I need to write my own tests for those cases just to make sure everything's going to be okay. You'll notice that kind of thing happening here. Questions 7 and 8. These are, as I say here, the challenge questions for people chasing high distinctions, etc. Because when you think about it, this is the top 20% of the marks in the exam, and it is not 20% of the possible amount of work you may have to do for the exam. When you consider question 1 was just like a couple of loops through an array, questions 7 and 8 are much, much harder than that. So I'm saying that this is just going to go all in. We're going to throw in everything we've taught in the course, and potentially the flow on from what you know from what we've taught in the course. So you like, in the same way as those challenge questions we've seen, you may have to think about how you want to do things using the tools that we have, but not necessarily the techniques we've taught you with those tools. You may have to go beyond, which is all about problem solving and using what we've taught you in an interesting way. If you want to see an example of this, we have an old question 8 in lab 10 in this week's lab. So the question that we have, I can't remember exactly how it's phrased, is we have a chessboard and a knight on a chessboard. So the knight can move in particular ways on the chessboard, and we, if I remember correctly, it's different ways to reach one square from another. I don't know if it's one square or it's like cover all squares of the board by moving around them, and print out all the ways that you could potentially do this. David, yes, knight moves. Oh, it's the shortest routes from one square to another. So you have to look at all the different ways the knight can move and say, if it can, in a sequence of moves, reach another square, print out all the different ways it could reach that other square, the shortest way possible. So when we get to these harder questions, we will also be giving partial marks because the questions are big, and if you can show that you were thinking about this correctly and you can implement part of it, it's okay. So for example, with this knight moves thing where you're going, okay, we want to be able to reach one square from the other. If you build up a function that says, here are the squares that the knight can reach from where it is right now. So we give it an input square and we say these are the squares it can reach. You'll get some partial marks for that because we know that you need that in order to solve the problem. So as I say here in this point, we're testing your ability to break a problem down into its parts, right? So we're not testing in 7 and 8. We are testing, I guess we're still testing how well you write C, but we're also testing, can you solve problems using programming that you don't have a kind of a copy-paste recipe for somewhere else. So you will get marks for your ability, because that's what, like, when we think about this down the line, further on, when you've learnt about programming, the thing that we want from programmers, the thing that we, as UNSW, that we want to deliver to the world in the programmers that we teach here, is the ability to solve problems that the world's never seen before. And that's like the truth of being a programmer, is like, if someone gives you a project to work on and said, here's a problem, can you please fix it for us? If you can Google a solution to that problem, then so could anyone else, right? That doesn't make you the super special engineer. But we want to train the super special engineers where you Google it for a couple of weeks. You know, you go deep and you look at this, and then at the end of those few weeks, you pop out the other side and you say, okay, I know exactly what this problem is. and I know that no one has solved it before, or at least if anyone solved it before, they didn't publicize what they were doing, so we don't know. There's nothing we can do to follow anyone else's footsteps. So what we're going to have to do is we're going to have to look at this problem, we're going to have to break it down into its parts, and we'll see if any of those parts are things we can solve. We solve them, we build it up. So that's where we are here in questions 7 and 8, is where we're pushing for that idea in you, that capability to solve unseen problems. And again, this is HD level. I don't require this of anyone at this stage, but I still would like to test it, and I would like to encourage that this is something that is worth marks. Okay, so we had some questions before about study. I've gone a little bit overtime on this part of the lecture, but I think that's okay. We'll take a break in a second, then go on to other stuff. So in terms of study, prep the basics, go through all the topics, and I say breadth of knowledge over the course is good. So if you just go, I want to use arrays forever, I never want to touch linked lists, I'm just going to study the hell out of arrays so I know them really well, you're in trouble. Half of the questions are on linked lists. We want you to know everything in the course at a reasonable level, not some parts of the course really well and other parts of the course badly. Revision questions. A lot of the tutorials have these revision sections afterwards with other questions. If you go back now, I think we've moved some of them into the correct tutorials for the topics they're in. Make sure you know how to use arrays and linked lists. There's a revision section that I'm pretty sure we haven't turned on yet, Tom, but we will be turning on soon on the course webpage. If you want to scale the topics at different levels of how important they are, the super important ones are the core topics, the things that are necessary to understand programming. So, can you use variables, can you use if statements, can you loop, can you write basic functions and use arrays and linked lists, right? And then the stuff that is not even extension, but the stuff that you're going to need to understand to be able to do these. You're going to need to know characters and strings. You're going to need to know pointer structs and memory allocation to be able to use linked lists. And then the stretch goals are the things that aren't going to be tested that much in the exam. If they're tested, they won't be vital. You won't 100% need them for particular things, but they may be handy. It's things like abstract data types, multi-file projects, and recursion. As I said, recursion's like, if you want to use recursion, you can use recursion. You can replace everything. All of your iterating, all of your looping, you can replace with recursion if you want to. There's a special achievement that gets you the platinum trophy on the PlayStation Network if you do the entire exam in recursion. That'd be pretty funny if like the entire course was just like based on achievements. At the end of it, your mark is based on your achievement score. So Gira-chan was saying Sean was asking, may have missed this. Practical questions, 1 program each. Earlier ones, few small programs. Harder ones, 1 big program. Not necessarily. So I think we're talking about the theory questions. Some of them aren't even programs. They're just snippets of code and ask you to analyze it. When we're talking about the practical questions, the 8 practical questions, we'll try to keep them separate. So we won't necessarily have, you need to use something that you've written in a previous question again. You may find that that's the case, because escalating difficulty generally is a situation where the techniques you used at the beginning, the easy stuff, will be used again, but chained together in a different way later. You don't have to do stuff in order like assignment stages. They don't lead into each other directly like that. Yeah, practical ones, 1 program per question. Yes, you will not write more than 1 program per question in those. So we'll ask you to do something that'll be contained. Talking about the way that we'll be marking the exam, most of the marking for the exam is automated in the same way that we've been auto-marking your labs and your assignments and things like that. So make sure your output format and the way that you're reading in stuff matches the specification exactly. If it doesn't match the specification exactly, the marking will not work. We will be hand marking things, but obviously if you didn't meet the specification for the input and output, we can't give you full marks, right? We can still look through and say, okay, this person didn't do the output correctly, but they understood everything else, and they implemented an algorithm that mostly works. We can do that, but it's not necessarily like we're gonna look at that and go, well, this person obviously didn't test this at all because it didn't match the output, so we're still like not going to give you all the marks. Your hurdles are definitely all going to be checked by hand. I should actually say it's not just your hurdles. Like anything else is going to be checked by hand as well. Like we're going to have to go through and mark this whole thing. This is the joyous hell of myself and some of the tutors. After your exams are finished, we have to go through and do all this kind of stuff. So again, marks are awarded for correct code. The marking criteria is not the same as the percentage of the number of tests that have been answered correctly. Some tests are much more important than others. So some tests are like, are you doing the core solution to the problem? And you get most of the marks there. And then other tests are, or have you checked for this random other occurrence? And a smaller amount of marks is assigned to that, you know? So it's that kind of thing. So the auto tests are not equal in marks. We're expecting the results sometime around the 18th of December. So your exam is the 4th of December. That leaves us about 2 weeks to mark the exam and finalize all the rest of the marks for the course, and then add it all up and stuff. Oh, Kat, you don't know the joy of trying to turn around courses. What is it? The thing I used to say, Tom, is term 2 was, we were finished in term 2 complete and had given everyone their marks back sometime around week 2 or week 3 of term 3. That's how cramped things are nowadays. Anyway, it's it's interesting. I mean, we're still getting everything done. We're still teaching everything everyone like that everyone needs to know. People are still learning what they need to know, but the admin at the back is a bit cramped here and there. Yeah. So yeah, after the 18th of December, we're all going to kind of pass out, I think, and then have a couple of months for next year. I'm not entirely going to pass out. I'm going on a holiday here. So I'm prepped for my holidays already. Oh, I do not have room for my face anywhere. I'll just move it around a little bit. Okay, so special consideration and a supplementary exam. So there's a rule at UNSW that if you start the exam, like if you decide you can do the exam, then you have to do the exam. So this is a thing called a fit to sit rule. So just be careful of that, in that if you're not feeling up to it, like if you're feeling sick, or you have other issues that you have to deal with or anything like that, don't start the exam. Because basically once someone has read the questions of the exam, then you're in and you have to finish it. So if you're not, if you're really not feeling well, you're feeling sick, then you want to actually go for your special consideration without looking at the exam, you know, because then we can give you another version of the same exam without it being, sort of like you're not going to get an unfair advantage like that. Having said that, for any reason that you need, you can apply for special consideration. If anything happens during the exam, let us know. So this email address, let us know. I know that this is very difficult if your computer, say, explodes during the exam because you've just been programming so hard, right? Hopefully you can still email us on your phone or something like that. Just get in contact with us and we'll arrange something to make sure things work out for you. The supplementary exam, because we're so late in term 3, won't be held this year. It'll be held in January next year. It'll be exactly the same format. So it'll be the 6 hours. It'll be the same question format and stuff. It won't be the same questions. So if you do need to sit the supplementary exam, set some time aside during that week of the 11th to 15th of January. We haven't been scheduled yet, so I can't give you an exact day, but know that it's sometime during that week you may need to do that. Yeah, as Tom said, thunderstorms, lightning, we've had a house fire, computer failure, obviously. Like, you know, like when we're doing an exam at UNSW, you run it on our computers. So if you have any computer issues during the exam, we just move you to another computer and give you a few extra minutes at the end to account for you having to move your code across from wherever it was and stuff like that. We obviously have no guarantees about the computers you're using at home. Again, this is why a 3-hour exam has been given 6 hours. So you literally have twice the amount of time that people who were doing this in person had, because we don't have any of these guarantees. We also don't have any guarantee that, I don't know, for example, your little brother or sister is going to run in and just yell at you while you're trying to concentrate, and then will completely throw off your focus for the question you're working on, right? That's why you have twice as much time as you would normally have for the exam. So a lot of stuff like that. But if you have any issues with the exam, email us on this email address. That can happen during the exam. It's actually active now, I think, Tom, so you could even email us in advance if you wanted to. Another thing that we're having at the moment is minor issues with timetable clashes. So we do have some people who have timetables allocated, exams timetabled on the same day. So COMP1511 exam timetabled at the same day as another exam. The way that the exams were organized in advance is we all said roughly how long our exam was going for, but most of us said that it's like the classification is all day exam if it's longer than a certain point. So our 6 hours is classified as an all day exam because it's considered you're doing 7 hours of work a day, so 6 hour exams all day. UNSW allows people to do 2 exams in a day, but the issue with that is sometimes they overlap heaps. So I've seen people with an exam that runs from 2 till 4 or something, and then they have our exam from midday till 6, and it's like, that doesn't work. You're not going to magically do part of our exam and then 2 hours of another exam in the middle and then our exam afterwards and be able to deal with that. So if you have a timetable clash and we know about it, we've already emailed you. Please check your emails. We have a form for people to fill out saying, okay, this is how I want to deal with the timetable clash. So there's a combination of ways that we will help you deal with the timetable clash. If you do know that you have a timetable clash but you haven't received an email about it, hit us up. We'll sort these things out. We don't want someone trying to do 2 exams at exactly the same time. You're supposed to be able to finish one, have a break, then do another. And so we will be moving timetables around for people to make sure this works out. Girichan's asking about VS Code. We have escalated the VS Code problem. So anyone who's using VS Code in SSH may be noticing that it's been slowing down as you've been using it. And we've seen a workaround some people have had of actually just deleting the VS Code server directory. The details will be on the forum somewhere. I know that Dean was talking about it, and so I think he's probably already answered the questions on the forum. So the VS Code's performance sort of drops as the longer you use it, and obviously if you're going to be using it for 6 hours, that could be an issue. So our system support know about it, and I'm not sure how much time they've had yet to dig to find out what the issue is, but we're hoping in 2.5 weeks that they will have found something by then and have a solution. General massive slide. This is the contact email. I've said this several times already. This is the contact email, but any issues with the exam before and during the exam, you can email us there and you can ask us, and we will do whatever we can to help you. We're obviously not going to give you any programming help during the exam. It has to be you doing the programming, but anything else that happens, infrastructure, any other issues, we'll help you with those. Okay. I always knew that first half was going to be bigger than the second half, but I just still wanted to break it based on content. So I just wanted to say a little thing about human memory. One of the funny things about this course that you may have already noticed, I mean, I've pointed it out before, is I've basically been memory hacking you the entire way through the course. The way that human memory works, and the way that we try to teach you, a lot of people will try to teach you in the same way, is that the repetition of learning things pushes things from short-term memory, which disappears once you stop thinking about it, into long-term memory. So it's like your RAM and your hard drive. Your human RAM is your short-term memory, and once you switch off, as in you just go think about something else, it disappears. But your hard drive is your long-term memory, and we try to make sure things go onto your hard drive. And you can do that by active recall, which means you make an effort to remember something multiple times with distance of time spaced in between them. For example, I show you something in a lecture, and I don't expect that people will remember everything that's in lectures. Then, 1 week later, you do that same thing in a tutorial. That's your active recall. You know, you've seen it, then you recall it. And then a week after that, you do that in a weekly test. You recall it again. If you do those things in that sequence, you are very, very likely for significant chunks of that to go into your permanent memory. And then you will never forget it. That might be the lyrics to Call Me Maybe by Carly Rae Jepsen that you will never lose, no matter how much you try to get rid of them, and they've just come straight back into my head again, and that will happen. For me, it's Friday by Rebecca Black. I will never be able to forget that song. But, you know, it totally... yeah. Yeah. So it's very much, yeah, as I've said, it's like repetition of memory works really well, but it's not just reading stuff, right? So just be careful in your study. It's not just skimming over things that's going to get it for you. It's slightly working on things. So you've got to push a little bit further into them, and then you'll have stuff going into your deeper memory like that. When you're studying, yeah, I've just earwormed everyone with those two of the greatest songs ever written. Get a little bit of exercise, even if it's just going for a walk. You can even grab your study notes or just put some like lecture slides on your phone or something, and go for a walk. A little bit of blood flow helps. So yeah, little tips like that. You could go into your mind palace. I don't know if anyone knows about the theory of mind palaces. It's so much fun. You can walk through an area that you know well. So you walk through the memory of your own house. So you enter the front door of your house, and you go through, and then each thing that you see on the way in, like you see just inside the door, you see the welcome mat, you see the door to another room, you see the corridor, and that kind of thing. Eric's like, yes, you know it from Sherlock, 100%. Yeah. If you do this, you can attach memories to things, and you can go through something that's easy to remember, and you've attached the hard to remember things to it, and then you can go through it. For example, you can do this with the lyrics to Call Me Maybe, and you can sing the song to yourself and go, oh, at that point in the song I remembered this thing about how to use 2D arrays, or something like that. So that kind of thing can work. All right, we're going to go on a quick break. This is going to be a quick break because I know that I've got other stuff that I want to talk about. So it's 12:33 now. We're going to come back at 12:35. So we're only going to take a 2-minute break. And then we'll come back and we'll start the speed run of the course. It's going to have to be slightly quicker speed run than I thought because I've only got half an hour left today. And so like Eric and Kat are saying, yeah, these totally worked. And Trent's saying, yes, you've played Persona 5. I haven't played Persona 5, but obviously there must be a Mind Palace in there. Okay, I'll be back in like 1 or 2 minutes, and we will continue. Uh, never gonna give you up. Never gonna let you down. Never gonna turn around and desert you. Anyway, okay, let's get into it. I remember someone who used to do that. They would actually like put headphones in lecture notes and stuff, and they would go through their study notes with particular music playing. But I actually don't know how that worked, because that was back in the day when we were doing exams in person, and there's no way that you can like listen to music during exams, because like how could you prove that that was just music and it wasn't just lectures that you were listening to? Giro-chan, you have the same lamp. It's me. I think it's an IKEA lamp. I think a lot of people probably would have that. Actually, that's true, Tom. So you don't even need the music. You can just sing it back, and then you'll get that. Okay. What do we learn this term? Reusing the meme. We learned all the things. So, we are going to go through the entirety of the course. I'm going to do as much as I can of this kind of first half of the course today, so hopefully I can get through this reasonably quickly. This is a speed run. If you have, for example, not been listening or coming to any of the lectures at all for the entirety of the course, and you hop in right now, this is a... Actually, no, it's not. I was going to say this is a good starting point. It's not a good starting point. This is a revision. So we're going to go through all the topics of the course with the understanding that you've actually covered it all previously. But we're going to summarize everything so that everyone knows these are the things in the course, and you've got this nice kind of set of things that you're going to work on. So, I should point out that all of the memes in the speedrun were given to me by a pair of students term 2? 2019 term 2 or 2019 term 3. I can't remember which one. Did I freeze up for a second there? It looked like my stream froze up for a second, but I think it's okay. Anyway, so all of these memes were given to me by a couple of students, and so I integrated them into the into this particular lecture because I thought it'd be quite funny. So I'm good in C. Then write hello world using C. Sure thing, buddy. I've written hello world using C. Alright, so we're off to a good start here. Let's have a look at everything that we have taught in the course. Roughly, not exactly, but roughly in the order they were taught. So, we had input output, so we had print statements and stuff. And we have a lecturer in charge. Hello. Hello, everybody. Okay. Input, output, and we had variables. So we had ways of storing information. We have if statements, while loops. In fact, I'm not going to go through this list because we're about to go through slides on all of this. It's roughly separated into first half and second half of the term, but it's not exactly that, because I think command line arguments were actually in the first half of the term, first 5 weeks. And also, like, this one little point here was nearly 2 weeks worth of work, so there's a lot more in this one. So I just didn't do exactly everything in columns because I had to fit everything on the slides. Okay, thinking about C as a programming language. So right back to the beginning. So it's a compiled language. Not all programming languages are compiled. Some of them are what we call interpreted, which means you don't actually have to run something like DCC and translate it into machine code that the computer can use. So there are other compilers. You may have seen them. GCC and Clang are two of the biggest ones that are currently in use for C. Strangely enough, DCC in its back end is using some of these to do some of its work. So the compiler is going to read the code. Alright, see you, Tom. The compiler is going to read your code line by line, top to bottom, and translate it into instructions that the computer can execute. And so that's it transforming it into that other file that you use when you do ./filename. All C programs have a main function that is the entry point for the compiler to say this is the thing that runs first. And if we want to, we can do multiple file projects. So you can see I definitely did not introduce this at the beginning when we were talking about C. It was unnecessary. But when we use our compilers to do multiple file projects, we compile the C files into code, and the H files we don't throw into the compilation, but we include them using the C files. Another little meme for the fun of it. When your code compiles the first time and then you're scared and you run away, which is a good response to things. Okay, input and output. Our very first input and output was using scanf and printf. So we were like, scanf is going to read information from the standard input, and printf is going to write information to the standard output. Wait. Let's just fix that up. The way we've been using them are the terminal. So the Linux terminal that has the ability to show us text. That's how we've been using our standard input-output. So both of them use these pattern strings. So there's %d, there's %lf that we've seen, %s for other things as well. So all of those allow us to format our inputs and outputs in particular ways. There are other functions that we use for input and output. Getchar and putchar is for single characters. Fgets and fputs will work for entire lines. Hopefully you've seen enough of these and printf and scanf to know that sometimes they're interchangeable. Sometimes you want to be more careful with things. Sometimes we also want to be able to convert input strings, for example, into numbers. This is particularly when we're using stuff like command line inputs, and command line inputs don't work with these format strings, so we can't turn them directly into a variable type. We'll need to we'll need to take something in as a string and then convert it to an integer. So stir to L is one that can do that. Speaking of command line arguments, every time we run a program, we can add words to the command line. The command line is the line we type in on, after the program's name, and they will get put into an array inside the program. That array is called argv. That's the array of strings that's inside, and argc tells us how many things were input. So command line arguments is another form of input to the program. Doesn't happen as the program's running, but happens like sort of just before the program runs. In case we need a demo of command line arguments, we've got this set up in our main. So if we have our main with the argc and the argv, and it will be in exactly this format, then our C compiler knows that we're going to take stuff from the command line. And if we do, the words are inside argv, and the number of commands on the command line were argc. So you can just copy paste this code if you want, and it's going to print out exactly this output. So it says, all right, I'll tell you everything that I got on the command line. And it's good to remember that it's exactly everything that was typed in, including the name of the program itself. So if you don't want the name of the program, you can always not use the first element of that array and just use the things that are typed in afterwards. Because generally you know the name of the program already. You don't necessarily need to read the name of the program as it was typed in. Okay, variables. Ways that we can store information in memory. We know a lot more about these than we knew in the beginning. When I first showed you ints and doubles, we talked about the values they can hold, we talked about how many bits they took up in memory. All that stuff is still useful to you, but now we think about even more stuff than that. Variables are things that we can pass into functions, so we can tell a function that it needs a value that has come from a particular variable. We know that we can address variables, so we can find the memory that a variable is stored in, and we can point a pointer at it. So we can say this pointer stores the address of this particular variable, that kind of thing. So there's more that we can do with variables than we could originally. We've learnt how to create our own variables with structs. We have learnt that we can type define variables. We're going to talk about this. Both of these we're going to talk about later in later slides. So there's lots of little things we can do with them. If we want values that don't change, we can use constants, which will often be done with the hash define. I think that one's called a macro, that says that one thing is equal to another, and so we can say we're not actually storing this in memory. we're storing it as an explicit value in our code. So if we want a number to not change, it's just going to run for the entire program. We'll use a constant instead. Really, really simple code for variables. I haven't referenced this in particular yet this term, but if I want to define, let's say define Goku here as 9001 because it's over 9000. Anyone who doesn't understand this reference, it's from an old TV show called Dragon Ball Z, and one of the characters in it is called Goku, and they have this weird thing about how powerful someone is, and they can measure it as a number. I don't know how that even works, but they measure someone as a number. And there's this line in the show, it's like, it's over 9,000, and everyone's like really surprised that it is. But yeah, so that's why I defined it as 9001 for that particular character. And this is just some stuff we can do with variables. We can do. I can see the Dragon Ball Z fans in the chat right now. So we can declare a variable like so. We can initialize the variable by giving it its first value, but we can assign different values to things, and we can make a variable that we declare and initialize together. I think people are probably pretty solid on variables now, hopefully. If statements were the first point at which we were able to branch code. So we were able to say that the code can run one way or can run another way. So we used if and else statements to do this. I think the next slide will be else statements. It's a question and an answer. So in here we have a question. If the question is true, we run what is inside the curly brackets. Otherwise, we skip past the curly brackets and we do whatever comes next. So I think that we probably know this one pretty well, but it's important that we know about this because this kind of format of a keyword, brackets, curly brackets is something we're going to use later in other things as well. Oh yeah, so I didn't even put else statements there, so I've just got that. Sorry, someone wants to go for a walk. You can sit up there. We also have looping. So looping was the first time that we started being able to run the same code more than once. So we used while loops. There are other kinds of loops, as people have mentioned. There's for loops as well, and there's do while loops and things like that. So there's all these other constructs available, but we can do everything that we need to do for the moment with while loops. Like, they're actually functionally identical to these other loops. It's just syntax, which is why we only bothered to teach you one of them. The trick with every loop is knowing how to make it stop. Yeah, so we know it's going to run multiple times, which means it could run forever. That was the first time I rickrolled you in class with Rick Astley songs. And so we need to make sure that every loop we create, we have a way of stopping it. So we can do things like check all the values in an array or a linked list. That's the basic thing that we would be doing, is looping through something. Or we can do a repeated task until we're supposed to stop doing that repeated task. So anything like that, repetition, the two main ways that I've shown you is either loop through data or keep doing something until we want to stop. So we've got another meme here about looping. This is a for loop, but this hilarious big brain meme, if I wanted to add 50 to a number, I can go and I can do it like this if I want to. We've got some code here from while loops. This is the array looping code. So this is the most fundamental while loop that we will use, which is we have an array that is a certain length. We're going to loop until just before that length, and that's going to give us the indexes of every element in the array. So this is the bog standard. This is the one that we're going to use the most. We also have a way of looping through a linked list, and this is going to be using pointers. So obviously we haven't talked about pointers yet in the speedrun, but you know about them, so we know that we can use this loop. We start off with a pointer pointing at the start of the list, and then we say if that pointer is ever equal to null, then we've moved off the end of the list. So either it was empty to begin with and it never loops, or at any point we would leave it. Then the way to increment now is to move the pointer. And the way that we remember this is that the pointer stores the location of something. So if I change what the pointer stores, so I'm assigning a new value to the pointer, that's going to change where it aims. Oh, Rahman says if we all simultaneously put malloc. If you were all happen to be logged onto the same VLab computer, it would run out of memory really, really quickly. I think if everyone used all the memory, because usually more people can log in. Like, we're not all given a full chunk of memory when we log in. It's expected to be able to handle that. I think I would probably get an email from system support at that point going, are you doing something in your course? Because a whole bunch of COMP1511 students all used up memory at the same time. I don't know if that actually happened during that memory lecture or not, if everyone was running the same code as me, because that was a possibility. Anyway, why don't you try it on your own computers? Okay, so arrays now. So looping went into arrays, obviously, because once we had the ability to do repetitive tasks, we then had the ability to use multiple pieces of data, and we had a way of accessing it all that wasn't going to get too cumbersome. So we loop through, and we can loop through this data. So remember, arrays are collections of memory. It's a single block of memory that is separated into sections that are big enough, each big enough for an individual variable. So I've got an array of integers here, and it's storing all of these individual integers right next to each other in memory. When we create an array, it's of a fixed length, so we will decide. Basically, we'll decide when we compile our code. We'll decide how big our arrays are. Anytime after that, the arrays cannot change in size because they're declared as a chunk of memory. I think the only time that we could do that differently is if we specifically memory allocated a certain size of memory and then treated it as an array. So there is a possibility there. Now that we know more about things, we could do it a different way. But otherwise, generally, we think about an array always being a fixed size, and we will not have names for the elements inside it. We will just have index numbers that we use. We've got some code here for arrays. I think this one is just giving everyone HDs, except someone got a pass, still passing. The ways that we can declare arrays. This particular way of doing it, with the curly brackets and the 0, will set up all the values as zeros. Otherwise, you can explicitly set up the values in an array, but then you have to give a whole lot of them. Or you can just not do anything with the start of an array, and you can use something like a function to loop through the array and set up its values. You'll notice assignment 1, we've got an example of doing that, where we loop through the 2D array, and we gave zeros to everything in the 2D array by actually going through. Actually, it wasn't zeros. I think it was 4s. I can't remember. I think 4s were black, and then we were doing other colors on it. Accessing via index. The index obviously doesn't have to be a number. It can be a variable as well. So all the basics here of what we're doing with arrays. Functions. I'm going to put my face over Eddie Murphy's there. I love this one. I love this particular meme because it's so dodgy that they didn't even recreate the meme in the meme generator. They just wiped over a section of it and then drew it in MS Paint. So that's like the skill level we're going for here. Is like, you never have to pass parameters. Parameters are inputs to a function if everything is in main. So if you never write any functions, you will never have to worry about passing inputs back and forth to functions. So obviously that's a smart solution to this problem. Obviously not. And it's reflected in the sheer quality of the meme itself. Okay, functions are code that we write that is separate to the other code. So it's not in our main, it's not in any of the other functions, it's on its own somewhere, and it says, when you call this thing by name and you give it the information it needs, it hops over, it actually adds the function to the stack, we know this now, and then it runs it, and then when it returns, it pops off the stack, and it goes back to where it was called, and it says, okay, I may have some information to give back to you. So functions will always have potential, well, they won't always. They will potentially have inputs and outputs. So there will be some information going in, some information coming out. It won't always be information going in and coming out. There's always the capability of not using those. But the trick is that the function is stuff that's going to be called on potentially multiple times to run. Move myself back out of the way. So some function code we have here. The basic setup we're often going to do is we will declare the function above the main, and that declaration of the function will either be in the file it's being used, but it might even be in another file, which is why we include header files before we run our main. So this function could be in this file or it could be elsewhere. So we now know that we can split these things up into multiple files, which gives you a stronger justification of why we actually had the declaration and sort of an empty declaration at the top of the file and then the implementation at the bottom. It was the idea that the header file is included at the top and the C file is just compiled with it somewhere else. But when we're using in the same file, we usually do it like this. We'll say what the function is, and then we'll say how it works later on. So this is a really, really simple one. It's a trivial function. And it just adds these two numbers together. And Rahman's saying it's really bothering that I didn't return total. I think I just kind of used a certain number of lines. I think that maybe you would actually get a compiler warning. Actually, I don't know if you do. With this code that says you never used total. But I think it actually says we did use it because we assigned a value to it. But yeah, we could put a line in here saying printf total. That probably would be more polite in this case. But what we're showing here is not really about what happens to the total. It's about the use of the function. So we know that in our main or anywhere in our code, we can call a function by using its name and then giving it the right types of inputs that it's expecting. So this is expecting 2 integers, and I've got 2 integer variables, so I'm giving the 2 integer variables as input here. Then we hit pointers. So this is where things start to get interesting because we start to think not just about storing variables in memory, we are now storing addresses in variables, and those are addresses of other variables. So now we have variables that access other variables. So we didn't have that before. Everything was like really kind of straightforward. But pointers are now variables that have access to other variables. So every pointer stores a memory address. So it stores the location of something else. So the memory can be any other variable that's in the program, or it can also be nothing. Like you can have a pointer to null and say later on we're going to point this at something. Or what we often do when we're using our memory allocation is whenever we call malloc and we get memory allocation, it's going to give us back a pointer. And so it gives us back a pointer. We store the locations of things. I think one of the fiddliest bits of pointers is all of this stuff here, all of this like annoying little symbols that we have to use. So the star is the symbol of the pointer. So it's going to be the way that we create them, but it's also going to be the way that we use them. And the star says, I want to follow the pointer to its location. So the star says, I'm going to read this address, and I'm going to walk to wherever this address is, and then I'm going to read whatever's in there. So that's what we call dereferencing. So the pointer is a reference to something. To dereference is to go where the reference is telling me to go, and then read the information. If I need to create a pointer to something, pointers have a value, and the value is a memory address, and gives us the memory address of any variable that already exists. So if I have a variable, and I say and of that variable, that's like creating a pointer to that variable. It's creating a value of a pointer that I haven't stored yet, but it's still a value. And we can pass the and of something into pointer functions and stuff like that. In the same way that if I want to pass something into an integer function, I can either give it an integer, or I can just give it a number. So giving the and of something is like giving the number, just the address. If I give something a pointer, I'm saying this address actually is stored in memory as well. We've used this heaps. Some people call it the stab, some people call it the arrow. This is the way of accessing a field inside a struct using a pointer. So I'm happy that I can talk about these things now, because previously when I was talking about these concepts, I had to just sort of hide the fact that structs exist when I first used pointers. So we only learnt about the stab once we'd learnt about both structs and pointers, but now that all of the stuff is in our past, I can talk about all the ways that we use these things. So when we use the arrow, what we're saying is we're following the pointer's address to a struct, and then we're looking inside that struct for a particular field. Is Josh about to say, no, we don't actually know anything about these things. Please don't hurt us. Um, oh, no, no, you're saying we don't ever need to use the dot format with structs, do we? No, it's actually really cumbersome to use the dot format with structs. In fact, I didn't even put the dot... Oh, no, the dot's not here because the dot will be in the struct side. So the dot format with pointers to structs is really cumbersome because you've got to dereference it separately, put that in brackets, and then put the dot afterwards. So it's really, really fiddly. So we're going to be using the arrow pretty much all the time we're accessing a struct via a pointer. We've got some pointers code here. So this is pre-structs pointers code. So this is just the pointers on their own. And really, really, like, pointers and structs go together so much that we're going to be using them together more than we would be using it like this. But simple things. To make a pointer, we can initialize the pointer with the address of a variable. So we've got a simple variable here. Address of the variable may be stored in the pointer. Now the pointer always has access to that variable. So I can say, what's the pointer's value? Its own value is an address. And then I can say, okay, so now that I've seen the value of the pointer, I want to see the value of the thing at the other end of the pointer. So I put the star on it to get the thing at the other end of the pointer. And then that says, okay, this is the value 100 that's stored in that variable. So that's the way that we're using pointers. The other thing that we can do is we can pass pointers into functions. And this is one of the most important things we did with pointers, is if we pass the pointer into a function, we are then able to access this variable from inside this function. And usually the rules of what goes on inside curly braces stays in curly braces would usually say these two are separate and they don't have access to each other. But if we get given the memory location of this variable via this pointer, we will be able to access it. Okay, I'm a little bit over time, but I just made it. So what we looked at today, we looked at the exam, the format of the exam, and some advice on what to study for the exam. Hopefully you have a decent idea now about exactly kind of the number of questions, the category of the questions, and how you're going to maybe approach them. And we've looked at the technical parts in the first half of the course. We didn't look at any of the non-technical stuff. So I've talked about problem solving, debugging, all of these like super valuable things for what we need to know about programming. We're going to do that on Friday. So on Friday we will come back and we will continue the speed run of the course, but we'll also look at the non-technical parts of the course while we're doing that. All right, I'm going to wrap it up there because I'm now 4 minutes over time, which is a little bit longer than I should have. I'll go into be right back mode, and I'll come back afterwards if anyone has any questions. I don't know if anyone has any lingering questions about the exam or anything like that, because I think that Tom was answering a lot of those in chat as we were going, but I'll come back anyway just to see if there's anything that people want to talk about, and then we'll wrap up after that. But official lecture is over here. All right. Thank you all. Alrighty, I'm back. I'm actually not expecting a huge number of questions today. Um, oh, no worries. I'm not expecting a huge number of questions just because we didn't do any code today, and I think all the questions about the exam were answered in real time as we were talking about it. But I'm here anyway, in case anyone wants to ask me anything. Raymond's asking, will we be coding this week? By this week, do you mean in the labs? In the tutorials in the labs, you will definitely be coding in those. I mean, what's in the labs this week is actually the practice exam. So, oh, in lectures this week, no, we're done with coding in lectures. If I showed you any new concepts and coded them in lectures this week, then we would have no time in tutorials or weekly tests to cover it. So I think basically if I showed you anything new this week, you would end up with a very, very partial knowledge of it. So I won't be doing any code examples this week. I'm doing the speed run of the course. There's going to be heaps of code in the slides, but I won't have time to actually write any of it. I may draw some diagrams. What was I going to say? There are some bits that I may want to go into some detail with using pointers and linked lists and stuff like that I may show some diagrams and draw stuff. But otherwise, mostly speedrun. So we're not really going to be coding this week. Yeah. Looks like we might be wrapping up here. I think, I'm wrapping up the whole course, so I can understand why there's no more specific questions. Ah, Trent. Okay, let's my new baby. I've gone through and programmed all the colors and the stuff on the LEDs because I think that's the most important. Josh, okay, Trent, before we go on to my my sidetrack here, Josh has a genuine question. So what percentage people normally get the last question in the exam? I think it's about 1%. And I'm talking about complete answers. So complete finished and 100% answers is about 1% of the course. I would say about, what am I thinking of? 5 to 10% of the course will attempt it. And a lot of those people who do get to that point and attempt it will be able to get some partial marks. Because if you can do questions like 5 and 6, you can probably get some partial marks in 7, maybe some partial marks in 8. So there's a chance. But in terms of people that absolutely do complete it, it's only about 1% of the course, which is good. That's where I want it to be. Like when you're writing an exam, there are a few things that are very dangerous for an exam. If the majority of your course gets 0 in the exam, then you have written it incorrectly. It's too hard. But also, if any significant portion of your course gets 100% in the exam, you've written it incorrectly. Because the more you hit the ends of the scale, you can see, the more you hit the ends of the scale off either end, the more you're not assessing people. So if, say, 30% of this course got 100% in the exam, then that's 30% of people I'm not assessing. So I'd only be assessing people correctly if I can actually tell how well they did. If they've just done so well, or I'm making out they've done so well in the course that they all got 100%, then I'm not differentiating them in any way. So I haven't really assessed the students properly. So that's why the exam has to have, there's questions in the exam that are literally copy paste this code in and run it, and then type in what you see when it runs, right? So I'm assessing the ability to start programming, and right at the other end, I'm assessing the ability to solve really, really difficult problems that you haven't seen before using the tools I've given you. So there's both ends, and so there's the chance for people to get a very small number of marks. There's a chance for people to get a very high number of marks, but I get a good spread, and I can see how everyone's going. Yeah. So yeah, Josh, that's the answer to that. Yeah, and you can get partial marks in those questions, so sometimes it's worth looking at. I've seen people actually. I think one of the interesting ones with people who are like, okay, I'm not really going to get into this, but here are my comments, and they go, I would do this, then I would do this, then I would do this, and I didn't really have time or like the mental capacity to continue, so I did this part of it, and then I checked out. And we look at that and we go, yeah, I'll give you partial marks for that. You actually had a complete algorithm for how you were going to solve that, and you had a working implementation of part of it. Just like, yeah, that's pretty good, you know. It's very different from the kind of partial marks we'll give for the earlier questions. The earlier question is like, loop through a linked list once and do some stuff. Like, that's an all or nothing. Like, either you did it or you didn't. Like, it's really, really hard to get partial marks in something like that because there's so little code involved. Whereas the, like, question 8, for example, might be, I don't know, I'm, like, ballpark figure, and everyone codes differently, so, like, let me say 200 lines of code. If it is 200 lines of code, then you can write, 30 lines of that code and score some partial marks. As opposed to, like, question 1 or 2, where it's like, I don't know, 8, 10 lines of code. There's very little actual code going on there. So either you get it all right or you don't. Yeah, so Josh, you're trying to gauge whether you can get an HD or not. Generally, I mean, it's a tall order for us to try to mark the assignments before your exam. Like, we're pretty busy. Having said that, you haven't even submitted them, so it's very hard for us to start marking them now. So if you could see all your marks, you would already have a decent idea about what your mark is going to be, because the exam is structured reasonably similarly to the assignment. Well, it's not really the assignments, but a lot of the labs and stuff like that. But the course doesn't change in difficulty in the exam. So if you look at all of your marks at the moment, and you're confident of a certain mark in assignment 2 as well, that's likely going to be your mark. Some people get better or worse in the exams, but it's not going to be a huge shift. Like, what you know is still what you know. Personally, I would usually always get very high marks in assignments, and my mark would always drop in the exam because my memory is not as good as my capabilities. Like, I think my skills are better than my memory, and so there's that kind of thing. So certain people are going to go up or down. Some people are better in exams. Some people are like, put me in the pot and boil it. Like, just hit me as hard as you can with the hardest stuff possible, and I will smash it. I'm not as good at that personally. That's why I'm a lecturer, and I'm not like, day trading investment banking or something like that. It's a different kind of pressure. Girachan's asking if HD is 80 or more. It's 85 or more. So a lot of people just kind of think of those grading brackets as the things that they're aiming for. So pass at 50, credit at 65, distinction at 75, high distinction, which is the HD, at 85 or higher. Generally, you'll find during your course at university, I mean, some of you are already, some people doing this at Gen Eds have already done lots of courses. Your bracket for your marks is usually reasonably similar all the way through. It depends, though. It's not always, like, some people shift in different directions. I started low and I didn't start getting, like, consistent distinction, high distinction marks until later in my degree. So, like, everyone's got a different path. And Josh is saying, yeah, sometimes you're trying to maximize your marks in order to get your weighted average mark, they call it, as high as you can. If you're doing an engineering degree and you're aiming for different classes of honors at the end, you want to keep above, I think, a distinction average. I think first class honors is a distinction or higher. I don't know if it's still that way. It was back when I was doing it. Yeah, so that kind of thing. Oh, so yeah, Girachan, if you've been studying in the US, I think it's they're on an A, B, C, D kind of thing, right? I would love it if they had S tier, but that's a Japanese thing. So they've got S and then A, B, C, which is really funny because that's now in computer games, and so you can be S tier in school. It's very funny. And Kat is saying yes. When you calculate your weighted average, it tends to be the later subjects are worth more than the earlier subjects because they're considered harder and more advanced. Oh, but Josh says weighted by units of credit. I don't know. I don't do that kind of marking. I do marking for people's actual capabilities, and then I hand it off to someone else. So I don't really know how your degree will go. I only know how this course will go for most people. Gira-chan asked what chicken specs are. Chicken, who is right here, just sitting next to me there, is a random Sydney, I think she's a domestic short hair officially, but I think she's just basically a combination of whatever breeds are wandering around Sydney. So I just adopted her from a shelter. And she is... she's 10 years old, and it might be her birthday sometime around now. I know her birthday's in November, but I've forgotten when the exact date is. I know I forgot my own daughter's birthday. But, yeah. So I think she's about 10 years old. There you go. There's chicken specs. There's a question. Genuine question. I'm going to answer like the genuine question about chicken specs. Dan is saying, for the testing part of the assignment for delete playlist, the first test was if the selected playlist was deleted, if it was the first one in the library, but I can't think of a second test. I'm not sure exactly, Dan. I think you'd have to look at that in more detail. But you're testing to see whether delete playlist has worked correctly or not. So you could say the first test is to test if the first element of the library was deleted correctly. You could do another test for something in the middle. Like whenever we're doing linked lists, I always think of this thing, right? What happens if it's the first element? Does our code work if it's the first element? What happens if it's the last element? Does our code work if it's the last element? What happens if it's one in the middle? If it's one in the middle, does our code work for that? You know, every time we were doing stuff with the linked list, we were like, okay, let's do the middle case. And then does the middle case work? It doesn't always work for other things. So let's do the first element, last element kind of thing. So maybe that's an example for what you could do for delete playlist. Make a larger list of playlists and then delete from different sections of it. That might be all you need to do for your testing. Yes. So as Dan's saying there is like, for the second test, could I just do the same thing as the first test, except for a playlist that's somewhere else in the list? Yeah, that might be a valid thing to test. Because if you're only testing for removing at the start of the list, you're only testing some of your removal code. Yeah. And the other thing you could test is the memory still fine afterwards? Although I'm not sure. I'm not sure if you can do a leak check in your testing or not. And people are talking about engineering honors. Yeah, Trent, that's what I thought, that engineering honors would weight different year subjects. It's not just units of credit. Don't take my word on any of this, by the way. I don't even remotely work in what they call programs, like degree programs. I'm very, very focused on course teaching. So I don't know how your entire degree pieces together. I mean, people ask me, I was like, what electives should I do? And I said, I don't even know which subjects are electives and which subjects are core. So, I know how to teach C, though. I know how to teach basic programming, and I've got a specialty. Yeah. Gira-chan's asking about horsepower and torque. Chicken is roughly, I would say, 1% of a horsepower. I think that if Chicken tried to run as fast as a horse, she would get outrun very, very quickly. What else is there that people are asking? Raymond saying, will help sessions run next week? I can't remember. Let me... Let's see what our timetable is. No, help sessions are running up to week 10, and then they will be stopping. So the help sessions are kind of there to do things like assignment support. and stuff like that. So in terms of study, help sessions aren't running. However, there is actually a study session on Friday afternoon. CSC Soc is running the study session. So you will have gotten that in the course notice. There was a link to CSC Soc's Discord. That's a Discord that's actually got to open on my other computer here that I'm on as well. So people have actually asked me questions there and I've answered. It's not really as busy as the course forum or anything like that. The course forum will still be running. So if you have study questions and stuff, you can ask them in the course forum. So a bunch of us will still be there. We're expecting the course forum to get pretty busy this weekend as well. So we'll see how we go with that. Yeah, and what I will probably do is sometime before the exam, so potentially during the week. The exam's on the Friday, so during that week, or what I might do is actually in StuVac when no one else has anything on, I might do a live stream. So I might do a couple of hours where I just sit down, open up VLab and say, all right, what do you want to know? And people can say, I'm not 100% sure on this particular technique. And I'll go, okay, let me do this technique, let me show you. It's like, you can be like, I'm not sure on removal from a linked list. So I'll be, okay, let's build a linked list. Let's draw the diagrams, look at removal and teach it again, So I might do like a study session like that. Expect that, I would say next Friday is a good time for it. So that'll be exactly 1 week before the exam. Other questions. We had questions about my new computer that I've just built. So I've gone for a standard strategy. It's like so funny. This has nothing to do with the 1511, but fun in general. So I've gone for a standard strategy that I do when I'm building a gaming machine. Is I look at spending a certain amount of money, but I will never take top of the line, because top of the line is always never at a good ratio of price to performance. So I'll go like one off the top of the line or somewhere around there to get decent performance. So CPU, as you can see, did someone actually see the AMD logo? I don't know how big that is on screen. But it's a Ryzen 3700 CPU. I translate glares at 3090. I am not getting a 3090. Like, that is, it's going to cost 3 times as much as a graphics card that's 90% as capable as it, right? So I don't like spending that kind of money. As Josh says, yeah, diminishing returns. Yeah. Oh, you didn't read the logo, but you recognize the look. Yeah. So it's got a particular look. So it's a Ryzen 3700, which is pretty decent. It's not top of the line. It's not even that close to top of the line. It's around, like, mid to high tier of new processors, which it makes it quite good. Like, it's going to be more than I need for quite some time. Yeah, and at the moment, personally, I don't know, haven't done that much research, but my thoughts at the moment personally are that the AMD is good for chips and NVIDIA is good for graphics cards at the moment. Yeah, so Ryzen 3700 CPU, the GeForce is an RTX 2070S, so that is a very good price point at the moment. When the 3000 series comes out, I think it's actually the 3000 series is already no NVIDIA the RTX 3000 series isn't out yet, right? So when that comes out, I think that will change the fluctuation on the pricing and stuff like that. But I kind of just wanted to get this going now, so I went for the 2070S. All right, so Trent, they're out, but they're not everywhere yet, so they're still really expensive. I have a feeling that they're just there's a bunch of people mining bitcoins that are snapping them. It's like everything at top of the line graphics cards are always in a bad place because people are mining bitcoins on them. So if people are making thousands and thousands of dollars with these things, then the price goes up. And so those of us who just want to play games on it, it's much harder for us to get a good deal on them. And Trent, you're saying that the Radeon, the expectations for the new Radeon is such that NVIDIA is getting a little bit scared of what's going on. So at the moment, I am playing through a bunch of the DLCs in Borderlands 3 that have been released that I hadn't played previously. Um, Hilariously, I've gone back to an old game with a bunch of friends. We're playing Mass Effect Andromeda. It's not a great game, but multiplayer, it's pretty decent. I mean, when I say it's not a great game, I just mean I got bored of it. I couldn't finish the single player, even though I really, really loved the earlier Mass Effect trilogy. I think that things happened to that game and it kind of drifted off. Cyberpunk 2077 is nearly the reason I bought this thing. Because I was like, I want a new shiny PC, so when this really, really kind of what is looking to be like a really amazing game comes out, I get to play it at like top tier, you know? Yeah. And Raymond, 100%, as you're saying, their games are always fun when you play with friends. So we were having a weird nostalgic conversation with a bunch of friends talking about old games and like the times we enjoyed, and we used to play a lot of Mass Effect 3 multiplayer, and so we hopped in and we all happened, and it's nice when we've all bought a game previously and we don't even have to spend any money. A whole bunch of us like, oh, let's just reinstall this old game and play it, and that's fun. Josh, be quiet. I will not speak to you. Josh said Shadowlands. I don't know if you know, I played a lot of World of Warcraft. Hang on, where is it? So this is a World of Warcraft Collector's Edition. This is the first World of Warcraft. So I pre-ordered this not knowing how good World of Warcraft was going to be. So this is like, if this was still in shrink wrap, this would be worth several $1,000s now, the original Collector's Edition. That would have been, I think that dates around 2007? 2006? I can't remember when WoW launched. So I played World of Warcraft in beta. So before it was a game, I played that game. So that's how deep I went in. I think I stopped this about 4 years ago. Prior to that, I was helping run a guild. So I was a 2IC for a guild that we spent 4 years continuously getting ahead of the curve raid achievement. So ahead of the curve is where you do the harder difficulty before the next tier of content is released, and we consistently got those raid achievements for 4 years straight. So that's so when Josh says Shadowlands, I'm just like, don't you tempt me. I can't do it anymore. Like I was working jobs back then where I didn't have the same level of commitment to my work as I'm doing here. So lecturing at UNSW takes a lot more of my time, and it's good. I get to spend more time with students, and I get to do a lot more stuff. And so I don't have time for that kind of, I think it was about sort of 10 hours a week commitment to make sure that we were doing that. So yeah, not necessarily doing that. And Coven, yes, this is a Tron t-shirt. So there's like, yeah, lots of like little gaming references today. Yeah. Oh, Trent was talking about the delays for Cyberpunk 2077. I think we're looking at, was it December 10? December 10th, I think, is the current release date that they're talking about. Carvin's asking me about Mass Effect 3's ending. I haven't played the remastered ending. I played the original ending. And it worked for me because I think that I played it the way they intended. So when I got the ending, I was like, yeah, good. Cool, that wraps it up. But I think for a lot of people who played it in different ways, it didn't wrap up correctly. Like, it was just like, how do we get there? You know? And so it felt like it was just, everything was brought back to something, even things that were way off in other directions and shouldn't have been brought back. So I think for a lot of people it caused a lot of problems. But for some reason, for me, I think I went through and I played it canon. In a sense, I ended up playing it the way that it was always leading towards that. And so I got lucky, I think. Yeah. Okay. we've gone way off track. I mean, like, lecture's over, so it's all right. We're a little off track now. So I think we should probably wrap it up here. I will see everyone on Friday, and we will continue our speed run of 1511 on Friday. So I'm gonna now go and play games. Not necessarily. I think that's actual work to do. But anyway. All right. See you all soon.